Good morning, everyone. Welcome back to the Daily Grind. I'm your host, Robert Layng. This is a podcast for Cutting Tool Engineering Magazine. I'd love to wish a Happy New Year to you all. Here's to a prosperous and innovative 2026. I hope you all had as wonderful of a holiday break as I did. The kids loved Christmas, as they do every year. And whatever holiday you celebrate, I hope it was the best. If you're just joining us for the first time, welcome. Thank you for joining the show. This show is an informal chat about shop culture and shop talk over a cup of coffee. Sort of a double entendre, grinding from machining and grind of coffee. Today's cup of coffee is Midtown Manhattan by Chock-full of Nuts. I had originally planned on just having the donut shop blend from a local supermarket, as it's what I usually have on hand at home. But I was in town running other errands and picked up a little bit of this Chock-full of Nuts. It's really good. I grew up having Chock-full of Nuts in my drip machine before I got a Keurig, and it made it really, really tough to leave my office each morning to go to actually do things. It smelled great. Speaking of coffee, if there are any coffee executives or anybody with a lead to a coffee company looking to strike a collaboration deal, I'm all ears. I've had a few companies' offerings already mentioned on the show, and I'm looking for a full-time collaboration deal. So if you're of the mindset that I get coffee and you get blasted over the airwaves for a really cheap advertising fee, let's make this happen. As you may notice, today I'm not broadcasting from the Acopian Engineering Center at Lafayette College. This is my last day off in my yearly holiday hiatus. I'm afforded a very nice leave of absence every year from work. So today is my last day off, and I'm broadcasting from my home here in Saylorsburg, Pennsylvania, a gorgeous rural town in the southern end of the Pocono Mountains. I will be back to broadcasting from Acopian next week. Side note, following week, the 19th, I will be back here at my home, as I'll have the day off. So, before we begin today, I'd like to take a special moment to wish my sister-in-law, Kayla, a great first day at her new gig. She is the new facilities manager for the Lancaster Science Factory in the beautiful city of Lancaster, Pennsylvania. Place is great. They offer a wide range of activities and programs to fit a variety of inquisitive young minds. They have a list of STEM programs on offer for little ones in pre-K up to summer STEM programs for visitors from all around. They have Cub Scouts and Girl Scouts centered programs, and they even host field trips for a day full of fun for young minds. Truly a spectacular place. Link to this site is in the video description. Please give them a visit and book your kiddo's trip. So congratulations to Kayla. You're going to be a rock star. Let's make our first cut of the day. This being episode 5, it is titled, Let Me Lay It Out For You. We're going to talk about layout practices and if it's still a viable and valuable tool in a machinist toolbox. This is brought up over the holiday break to me to talk about, and this is, I believe, a good thing to talk about in the age of CAD, CAM, and CNC machining. I still think it's very viable. I still think it's very valuable. And I'm going to lay out a few reasons why. Before I begin, a short backstory on the origins of layout, at least I've come to know it. When I was in my high school vocational tech school, the Northern Tier Career Center, sadly, now closed down permanently, a point I touched on in my first episode, sadly enough. I was taught to do layout on a steel block to learn the principles of it. We learned how to coat a part in layout fluid. Dykem was our preferred product. We had both steel blue and steel red. Then we used various scribing tools to precisely etch the lines and arcs into the surface of the part. This correlated to the cutting and shaping that you wish to do. We had an entire week's lecture on the practices and uses of it, followed by the remainder of each day in the practical use of the principle. We were given simulated repair parts with prints and a piece of steel to cut in the saw. After we squared up the ends on the milling machine, we coated the top surface in blue Dykem and allowed it to fully dry. Every one of us learned mighty quickly just how to be judicious and minimalistic in application of the fluid. Being the thinner the layer of fluid, the faster it dried and the sharper and more precise the etching of your lines and arcs would be. Then by reading the print and setting up height gauges, using our calipers, circle templates, we use carbide tip scribes to physically etch the desired geometries into the surface of the steel plate. This allowed us to use standard repair shop equipment like drill presses, saws, and files to accurately and precisely produce the desired part. It was both an assignment and a test of our skills for the week. Fast forward to 2 weeks before the end of the year of my time at VOTAC, as we called it. We had to take a test called the NIMS test, or NIMS, and it stands for National Institute of Metalworking Skills Tests. There were various tests to complete, ranging from drafting and CAD use to the typical mill and lathe tests. You had an intricate part to mill and one to turn. Even some surface grinding and CNC tests. That was mostly the writing and understanding of code. The one thing that made a lot of my fellows and myself stumble was the test for layout. The test had a print, and the title block had the part named mill block, and I'll forever remember that cursed print and accompanying test. We had to cut another piece of material, square it up, brush on the fluid, let it dry, and then set up some height gauges, the templates, calipers, just like I mentioned. And we had to just do the layout part of it. If you misread a dimension or you didn't double check your numbers before you etched, you either have a failed test or you'd have to spend the time to start all over again. And we didn't have a lot of extra time to take this test. It was timed and we were on a limited schedule while we were there in the morning. Needless to say, we cut an excess of spare blocks to avoid the need to wait for the saw to cut it up when, not if, we hacked it up. The steel recycler made bank on us that year, 2006. I remember it vividly. It was the year I graduated high school as well, not to date myself. See? All that to say that we learned the importance of an old technological skill in the hopes of two things. First, it is the progenitor to what we use now. And two, if it would be of use if we ever found ourselves in a situation in which we would still need to use it. While I'm grateful to have learned the principle and learned that it is the progenitor to the current state of affairs, I am more grateful to know the second of those 2 points. The fact that if I ever needed to use it again, it would be a familiar process to me. I cannot begin to tell you how many times I've had to use it to lay out a part in the work that I do from start to finish, both in the repair aspect and in the fabrication aspect. While I know those two words can be interchangeable for instances, for today's intents and purposes, it's not. As a lot of you avid listeners and watchers will know of my background at Lafayette, we are an in-house machine shop that provides prototyping and some basic production for our engineers. And being that we are prototyping, we do a lot of one-off. We do a lot of single-piece things or one run of something. And we don't necessarily have blueprints. We don't have a lot of blueprints, as a lot of these designs come from thin air, which is a real challenge, but it's also very rewarding. So not having prints, we have to make our own. And sometimes making the print is actually drawing the part on a piece of material, or taking an etch or a sketch from a bar napkin or a piece of paper and putting it right on the part and transferring it, a form of layout. So for your avid watchers and listeners, you'll remember that I've broadcasted from the race car garage at Lafayette's Acopian Engineering Center, and that race car project will be the basis for this part of the talk. If I may make a pun, I'm going to lay it out for you. Before the days of the water jet, and even still to this day, if I don't feel like going through the headache of starting the machine up, drafting the part, getting the sheet metal, homing the machine, and set it up for one part. I'd spend almost an hour getting that thing ready to cut a 5-minute part. Very wasteful in my eyes. But again, time isn't the factor here. But I would take a piece of sheet metal that was roughly sheared to about an inch oversized in length and width, and square one corner up with the shear, and make all my measurements from there by either using Dykem or a Sharpie marker to coat the spots that I'd be scribing a line for cutting. Using calipers, height gauges, and circular templates, I'd lay out floor pans or the firewall that goes between the driver and the motor envelope. I could then use a shear, drill motors, drill press, or files and tin snips to completely fabricate those floor pans and firewall panels, freeing up the water jet and the milling machines for much more intricate and precise work. I've also used the layout process just mentioned to check my work at the machine as well. I know it sounds repetitive or wasteful, but it has saved my bacon more times than I care to mention. Let's say also I only have one piece of a specific or exotic material to work with and no spare bar stock, as is the norm in our shop. We have lots of spare bar stock, as we have a lot of typical nominal sizes available to the students to use, and we point them in that direction to take nominal material so they don't have to order specific oddball things. Anyway, I'll take the time to do all the layout work on that piece of stock to verify my movements and locations for each operation. If the holes I need drilled are in the locations laid out and the parts milled to the lines etched, it's a pass. And it may seem like a waste of time, like I mentioned, but having the validation that I've cut the part and made the part exactly as it's been laid out, or having something to check my work with without having a failed part, I'll take that loss. Another one is oddball thicknesses of sheet metal. So we get a lot of work from our mechanical trades and facilities operations department out of 50 thousandths thick brass or stainless steel kick plate that you would normally bolt to the bottom of a door. In this case, I'd again take the time to coat the surface in whatever color Dykem that would stand out best. We'd let it dry. Compressed air has been a real big help for getting that stuff to dry quicker. I know it puts waves in the lines, but it doesn't bother us. Then I take the time to lay it out depending on what the customer wants. Like I said, a lot of their work, fabrication work, comes to us without a blueprint, mostly because they are on the clock. They don't have the time to sit and draw a part, or they know what they want in their head, but putting it on paper is a waste of their time. So they bring it to us and say, I want X, Y, Z, and we work our magic. And that allows us to draw the piece that they want on the part, show it to them. If it's what they want, we make it. Now, back to the race car. I use this process a lot for the frame. So many people that look at the assembled frame of the car, whether it be on a tour, as the background of my show, or the students coming in for the first time to join the project, they see it and think it's cranked out by some robotic marvel and it just appears on our doorstep like that. Wrong. While we do get a lot of help from a company in Canada, I believe it's Coordinate Systems or V3 Systems. Don't quote me on the name, but I'm pretty sure that's who it is. They take the model of the frame that we have. They take a model of the frame that the students have finished designing and source all the steel tubing, laser cut it at the fitting areas or the nodes. So a lot of in frame design, where tubes meet is called a node. So they wire laser cut the nodes, fit them together, and then weld them solid. We've done this for maybe 3 or 4 frames that I'm aware of. I've worked on the car for 15 years now, and we've had a couple frames come that way. And those frames came from a team that had all of their ducks in a row and knew what they wanted from the outset. So they just did it and got it, and and made it work. They did small changes, but they made it work, and they knew what they wanted. So those are rarities among the frame generation. But a lot of what happens is the old way, and the way I still use to this day. It's a way that I can use to control every cut placement, fitment, weld prep, everything, is to take the piece of tubing, coat both ends about a foot in with blue Dykem, dry it, and then I set a height gauge for 1/2 inch, being 1-inch tubing. I strike that line that entire foot length. That denotes top dead center of the tubing. And then we would put it in this junker lathe that we have in the back of the shop that really couldn't hold a tolerance to save its life, but it's great for fabrication work. There is a mating jig in the compound of that lathe with a line scribed at every 5 degrees in a circle. So what would that be? That would be 20, 60. Again, it'd be 72 lines. So every 5 degrees is a line, and it allows us to do a rotational cut. And then the compound has 45 degrees either way, so I can do a compound miter with a hole saw in the headstock and just pass the tubing right through it. But the point being is we do the layout on the end of the part. Well, it's very simple. It's just a simple straight line. That allows us to do 180 degrees of cuts in the rotation and 45 degrees either way for the miter. This gets us 2 stones in 1 bird, or what? 2 birds in 1 stone. I keep making that thing wrong every time. So we call it fish mouthing, or in the design world it's called notching, where we cut the half round of the tube that will be joining to the one that we're cutting. Just like subtractive manufacturing, we're cutting away so something else fits. This allows us also to do multiple intersecting cuts on the same piece of tubing with just that one line scratched across the top. This jig was set up over 20 years ago and still used to this day, and it'll probably serve us well into the future. Now, the next example is the manufacturing class that I've referenced multiple times on the show, ME210. The students, while they spend the first half of the semester working on a project that's predetermined, they have prints from us that we know work. They learn that aspect of it. But they're also doing something for the first time. So while they may have prints, they may have blueprints for us to make a part, there are a lot of times where they come with the print. I still have to lay the part out on a piece of stock or put some Dykem on and strike a line for us to follow on the vertical bandsaw. These are all very simple but useful methods. In the repair aspect, so every once in a while we have a job where we're repairing a piece of equipment for which we have no blueprints. And the way that I laid out for my NIMS test is the method we use for making our repair parts. So we still buy jugs and jugs of Dykem. I know it's kind of an old dying thing, but it's still very useful in my opinion. Now, these are just a few examples of how I feel layout is still a viable and valuable tool in a machinist's toolbox for the 21st century. There are some detractors to this theory that vehemently believe that with the advent of CAD, CAM, and CNC machinery and modern CMM technology that all layout's a blast from the past. Fine. I've heard stories of how it's used, or how it used to be used on the actual machines to denote your depths of cut, or when you're generally close to positions where you have to start measuring. My father gave me an example. When he worked for his father at their shop, they would put Dykem on the cross slide and etch lines and have a little finger sitting on the machine. And when the cross slide got to a certain point, that they knew to start getting their calipers and micrometers out to measure. Otherwise, those were just rough cut lines. It was a very quick way to remove material fast and not have to worry too much about making your first measurement after a skim cut, what have you. It was a way to do production fast in the days before DROs and CNC. Speaking of DROs, I was trained in the age of DRO, and it was way past its infancy. It was a readily available and widely used technology. So while I learned the old way of getting rid of backlash or laying parts out, I also had learned on DRO and CNC machinery being so prevalent. I've even talked to some machinists that are aware of it, but never actually used it. That one perplexed me a bit. They've seen it on YouTube, they've seen it done before, but because of the proliferation of automated equipment and super precise glass scales, they never did it themselves. And that one took me a minute to wrap my mind around. One more method that's still used today, and I think should still be taught for making custom gaskets. You can use the methods I've described by calipers and measuring tools and etching the surface and cutting it. But an easier way I've used is to place the gasket material right over the part and tap on all the edges and corners with a ball peen hammer. This physically cuts a custom gasket to your part. I've learned a lot of tips and tricks in the trade in my day, but what are some that you could share? Please reach out. I'd love to hear what you have. And I don't know everything, but I love learning new things as well, new or old, however you look at it. Speaking of hearing from my audience, I'd like to give a special thanks to all of you that have reached out in 2025 with feedback on my first 4 shows. It's greatly appreciated, and it goes towards making the show better for you all. I have a little request of you all. If you have ideas of what would be a good topic to speak about and personally important to you or your shop, so long as it fits in the realm of shop talk, I'd be open to bringing that up for you. Please contact me directly. I love hearing from my audience. Now, I'd also like to take a minute at the end of the show today to share with you the distant future, or near distant future, and the layout of of the daily grind for 2026. So for 2025, when we kicked off the show, it was a new thing. And as with all new things, we were kind of wading through everything as it came to see where we succeeded and where we were in need of more attention. And all of the topics were self-generated. I worked with the crew at Cutting Tool Engineering, and we put in a lot of legwork to come up with the things to talk about. I've had a lot of support from them, and I cannot thank them enough. I still have all that support to this day. What did change, however, was the topic calendar for 2026. I'm still pinching myself when I say that year. I don't know how it came on us so fast. Now, for January, the topics are already laid out. Again, another pun. I know it's, beating a dead horse here. The overarching theme for January is shop talk. So these topics are rather fitting, the ones that I have laid out. So February brings us to the realm of milling in all of its forms. There will be 4 episodes covering different perspectives on milling. March brings us to the world of sawing. And if you're like me, I really, really, really am, or was, naive when it came to sawing. It was something that was between me and making and putting a part on a machine. It was to get the slug of stock and get the heck out of the way. After having read back issues of the magazine, I realized that there was a lot more to it. Tooth geometry, bands, the bandsaw material, all of these things come into play, and people make a lot of their life on it. So March brings us to all things sawing. April takes us to the world of grinding, and a special teaser is we have the vaunted grinding doc, Dr. Jeff Badger, on tap to visit the show. I'm really amped for this one. It's also the birth month of my 2 beautiful daughters, so extra special for me. May takes us to a place dreaded by just about all machinists: measurement and inspection. Has that ornery bum in QC ever cornered you on the shop floor just to tell you how much you hacked something up? Or just how close you were to tolerance, but you missed it by that much? Who gets the reference? Tune in to hear the commiserations of your fellow manufacturers, among many other things. It won't be just a hate session. June has us rolling down the streets of turning. Special guest Aries Spicer the machining doctor, joins us for an extra special episode this month. Be sure to tune in. July is a trip down the lane of jigs and fixtures. With work holding being a topic that is in the forefront lately, if you guys have been reading the magazine, just about every other advert is some form of work holding. Jigs and fixtures are still like layout, I think, an antiquated yet still very useful form of work holding. So there will be 4 episodes on old and modern jigs and fixtures and work holding. Please tune in. August, we'll be screwing around with threading. I have a few little morsels of talking points that I think will ignite some real feedback. I'd love to hear what you have to say after you see the show. September has us getting a grip on tool holding. This one took me through a little bit of going back and looking at all the options we have and all the things that contribute to work holding, or tool holding, excuse me. We already did work holding. The tool holding, and just how much work that is in choosing the holder, all of that. So September will be a good month. October has us getting a facelift in the world of face milling. That's another one where I really just did it when I had to, not realizing how important of a process it is in manufacturing. How about another pun? November has us honing in on tool sharpening. So, in college myself, having gone for the toolmaking degree, we spent a couple weeks of one of our heat treat and grinding semesters on tool sharpening. I learned a lot of great things. One that stuck with me a lot was drill sharpening. I'm in the process of getting somebody from Derek's Drill Sharpeners to join us for one of the episodes. I'm also going to go over some tips and tricks that I've used and still use to this day, referencing my article that I'll have for the November issue. December is one of my favorite times of the editorial calendar. Back to a version of Shop Talk. This will again be a 2-episode special covering a wrap-up of 2026 and projections for 2027 in the future. I invite all who are watching and listening to suggest topics and talking points. Again, so long as it's in the realm of Shop Talk, no idea is a bad idea. A couple last asides before we close for the day. Oh, pardon me. I will just add that I've also had the honor of gracing the pages of Cutting Tool Engineering with an article on just about each and every one of the topics listed above. My work comes from the viewpoint of a prototyping shop, which I feel delivers a unique perspective on the work I come across and the manufacturing I do. I think you're all in for a year of good reads. I will, of course, be joined by the vaunted veteran contributors and authors that have been diehard assets to the magazine since way before I came on board. Here's one final toast of forging ahead to a great 2026. I thank you all for listening. Be sure to tune in again next week, January 12th, where I will have Chris Tate, the general manager of Browning Oil Tools, on to discuss preventative maintenance in a show titled Preventative Maintenance is No Issue. Have a great rest of your day, and may your only daily grind be the coffee in your mug. See you next week, same time, same place. Bye-bye for now.